Hey, everybody. It is day 6 of the Advent of Code. I thought I'm streaming this live, but I'm also going to record it for the YouTubes. And I just wanted to go over day 6, see what I can do to solve it in Rust. So with all that being said, again, I'm always interested in your guys' input and what you're doing. Let's get into the problem. So, day 6 is wait for it. If you've been following along, we've been trying to make our way through these islands, and one of the things we're missing is sand, and we're trying to figure out. We helped a farmer yesterday, and so he gave us access to a ferry to get to a new island. So the ferry quickly brings you across Island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you don't see anything besides lots of water and the small island where the ferry is docked. Should I share my desktop so you can see it? You can read along with me. As you try to figure out what to do next, you notice a poster on a wall near the ferry dock. Boat races, open to the public. Grand prize is an all-expense-paid trip to Desert Island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. Okay, it sounds like we're going to do a boat race. You manage to sign up as a competitor in the boat race, races just in time. The organizer explains that it's not really a traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. As part of signing up, you get a sheet of paper, your puzzle input, that lists, the time allowed for each race, and also the best distance ever recorded in that race. To guarantee you win the grand prizes, you need to make sure you go farther in each race than the current record holder. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and then releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and the boats don't move until the button is released. Okay, I'm not sure how all that fits into the puzzle. We'll have to wait and see. For example, times, and then it gives a list of times and then a list of distances. Let's see. This document describes 3 races. The first race lasts 7 milliseconds. The record distance in this race is 9 millimeters. The third is 15 with a record distance of 40. And the second, did I say third? The second is this. The third is this. Your toy boat has a starting speed of 0 millimeters per second. For each whole millisecond you spend at the beginning of the race holding down the button, the boat speed will increase 1 millimeter per second. So because the first race lasts 7 milliseconds, you only have a few options. If you don't hold your button at all, it goes nowhere, I presume, yep. Hold down the button for 1 millisecond at the start of the race, then the boat will travel at a speed of 1 millimeter per millisecond for 6 milliseconds, reaching a total distance of 6 millimeters. Okay, yeah, so the total time is 7 seconds. If you hold it down or milliseconds, if you hold it down for 1 millisecond, that's one of the 7, and then the rest of them go 6. You go 1 millimeter per second after that. So if you hold it for 2, you have 5 milliseconds left, but now you're going at double the speed, which gets you to 10. If you hold it for 3, you now have 4 milliseconds left, but you're doing it at triple speed, which gives you 12. 4 is the same. You wait 4, but you get 4 at 3 milliseconds. And then 5 gets you 10 because you only have 2 seconds less. 6 gets you 1, or 6 because you only have 1 second left. And if you hold down for 7, you get back to 0. So there's clearly some, like, gradient of, like, the best time. Since the current record for this race is 9 millimeters, there are actually 4 different ways you could win. You could hold the button for 2, 3, 4, 5 milliseconds. Yeah, those all 2, 3, 4. Those all produce a larger value than the record of 9. Okay. Since the in the second race, you could hold the button for at least 4 milliseconds and at most 11 milliseconds to beat the record for a total of 8. So between 4 and 11 inclusive, right? Give you 8 different ways to win. In the third race, you could hold the button for at least 11 milliseconds and no more than 19 and still beat it for a total of 9. To see how much margin of error you have, determine the number of ways you can beat the record in each race. In this example, if you multiply the values together, you get 288, 4, 8, and 9. Okay, so for each race, we're going to do a calculation on how many times we can win, or how many different ways we can win, and then we're going to multiply all of those together to get the solution. Okay, so the initial, these are relatively small, but as we saw yesterday, that may not actually help us. The thinking, though, might be you could potentially just iterate over all the solutions. Let's look at the input and see if that's actually going to be realistic. 46, 80, 78, 66. It is small, so you could potentially, for at least for part 1, I'm sure part 2 is going to dork it up, but for part 1, you can potentially just iterate over all the solutions. So maybe we just start with that, and that will help us work on input stuff. What's happening here? Okay. Sorry, I was just looking at other stuff. I guess that's what happens when you're doing it live. We're doing it live. Okay, I mean, let's just start with the brute source solution. Although I would like to think through, like, you notice it kind of creates this bell curve thing, right? And then if you kind of draw a line at 9 millimeters, all the ones that are over the bell curve are the winners. And so there may be, it's not really a bell curve, but you are creating some curve, like a parabola or whatever. And then, not a parabola, yeah. Holy cow, is it a parabola? Yeah, this. So you're creating a parabola, and you're going to draw some line along the axis and say, what is the solution? It may be worth thinking about that for a minute when we get to part 2. Because my guess is it won't be as easy as part 1, but we'll just try. So, given that, let's get started. Here we are on day 5, my stuff yesterday, but if we'll make it day 6, and then we'll just create a new one for day 6 and hop in there. Oh, I actually wanted to, I need to do this LSP add stuff to help with my syntax checking and stuff like that. Yeah, see, I get this because I have multiple, but I can do add the folder. And then if I go back into this, it should initialize the LSP. I should try and figure that out. Like, is there a way for me to add folders automatically when I start a new thing? Anyway, make sure we're big enough so you guys can see it. And then let's get the inputs. We can use nom to parse this pretty easily, I think. We'll start with the test input because we know the answer to those as well. Okay. So let's just start thinking about what that looks like parsing wise. We are going to have, we probably want these in pairs. So we should create a race structure. Which has a time of usize and a distance of usize. I probably don't have to do usize. I'm just used to always using usize. But then let's do some parsing with it. So we need nom. So we want to create a parse function where we get some input as a stir, and it's going to return a I result is what nom uses, right? And it's going to return the string and a race. So that's what our oh no, it won't. We actually don't have to do this. I think we should just parse numbers. So let's just create a new that has the time as a usize and the distance as a usize. And return ourself, and that will be self time distance. Yeah. Okay, so now let's think about the input. We're basically going to have two lines of strings, two lines of code, or two lines of input, and we kind of just need to skip to the end and then parse each of the integers. I think we can still use nom to do that, but maybe we just do it in a more iterative way instead of like a structural way. Read to string, the input. Wow, that gets really big when you're doing it like this. So now that we have the input, let's use nom's first line or we'll use the first line to get the times. So we'll say like let input times equal it's going to be a tuple. And the first part of the tuple we want is what? We want to get rid of the time, so we'll do a tag time. And then the next part is going to be spaces. 1. Is it spaces in nom? Nom. The Nomicon? Nomonomicon? It had a link in here that I actually liked better. Repeating? Somewhere in here had a link that literally had it all that was really useful. Nom get. Let's see if we can find it in here. In the documentation. Yeah, choosing a combinator. I think this was it. So is there one for spaces? Is space? It's called multi-space 0. Okay, so we're going to do the time tag, and then we're going to do any number of spaces. So we're going to have one block in here. And then we're going to do a separated list where the separator is multi-space 0. Oops. And the thing is digits 1, and so we'll get the input and unwrap that. Let's see. Import that. Import that. Import that. Okay. The expression has type. Let's just look at what it's saying in the thing. Oh, it's like this, huh? Is that what it's not? Let input equal tuple. That made it worse. Starting by fighting the compiler. Public FN tag is bound by this function, required this compared T. Yeah, it's doing it as a string, but we don't. We may be able to coerce this if we do like. Like this, where we say we're going to parse the input string and get a set of those. Oh, we can do AI result of stir vec race. Like the end result is that, and then we can do let races equal Parse input dot unwrap. What was that? I result. Oh, I did this wrong. So we can do that. And then the distances will be the same, right? Oh, yeah, right here. This is where I think it's actually helpful to where AI is helpful is, yeah, the distance is going to be the same thing. We now have distance, although what is it? It is called distance. There's some number of spaces and they're a separated list. And then what do we do after that? We now have the distance times and the distances. So we can do times dot map. We want to turn them into integers. So we need to do an iter dot map like that. But we can actually do some chaining. We can zip it with distances and do the same thing. And then now we have two integers, and so we can just call a map on that where we have a time, and a distance, and we call race new on that time distance, and then we collect that. Wrap this whole thing in an OK. Iter map usize parse. Oh, I did this in the wrong. We want to map. That should be the zip, and then we want to map here, here, here. So this, 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 that, this, like that. The method chain. Oh, unwrap. We want to unwrap these. We'll just presume they'll work. Closure expected to take a single two-tuple argument. Yeah, that's what I thought. So I'm still doing something wrong here. In Rustland. The method call may not have the associated types. Value of stir race cannot be built from. Oh, we're just missing this. And we need to make it a tuple. Okay, there we go. Yeah, that was just a nom thing to parse it like this. but that feels like it does it, right? So the idea is we parse the times line where there's time, some number of spaces, and the separated list of digits by spaces. Same thing for the distance. And then we can do an iter map zip of the, or we do a times iter and zip it with a distance iter where we have the u sizes equivalents. We map that to race new and collect those and return the output. So if we, let's do the test input and we print or debug races, see what we get. Race doesn't implement debug. Oh, there's a new line. So we can just do a let input blah equals this. Still not. No. Separated list on line 47. Okay. Let's see if we can see which one it is. The unwrap failed. Result, panicking. Sometimes the stack traces don't feel helpful. On input, empty string code separated list. So one of these separated lists is not working. Maybe I'm doing this parsing wrong. Tag time, multi-space. I could even do the new line right here. And I don't need this. And then I can say ignore this one as well. I presume it still does the same thing. 255. Yeah, I don't see in this unwrap where it's telling me what's going on. Or the stack trace. But I get an empty input on separated list. What if I debug the input? What does it look like? Time. Colon multi-space 0. Recognize 0 or more spaces, tabs, carriage returns, and line feeds. Oh, I think I've had this problem before. Sometimes the multi-space doesn't, these type of things where it includes carriage returns and line feeds don't work because it now sees this new line and now it's going to do this right here. It's trying to do this. It's saying like, where's the rest of my digit? But there's nothing left that accounts for it. So how did I do this in day 5? Maybe I can look and see. Oh, it wasn't day 5. There was one where there were like spaces around it. Was it day 4? Separated list space 1. So maybe I probably just do that. I just call space 1 instead of multi-space. Let's port space 1. Still some input error. Sometimes, I mean, I feel like it's pretty cool to use num. Oh, I'm still using it right here. There we go. That probably worked. 7, 9, 1540, 3200. 7, 9, 1540, 3200. Yep. Okay. So that feels like we have the input done. Let's check and see now how we might solve this problem. So within the impl race, we can probably do this calculation. If your boat has a starting speed of 0, basically just iterate over every millisecond and calculate the times to start. So you'd say fn distance, or how do we say winners for self, and that's going to return a usize. And we'll do like so we'll set this part is right. I'm not going to start with there, but we will start with the for I in start at 0 time and go to the end time. And then for each of those times, once we do this, we'll return the winners. But for each of those times, we say, let's hold down the button for that time. And so the distance is what's left over from the total time times this I value. Is that right? Let's just look at the numbers. If it's 1 millisecond, then the distance is the leftover time. 7 minus 1 is 6 times 1, which is 6. If it's 2, it's now 5 milliseconds left times 2. 7 minus 5 is 2. So the distance here is equal to self.time minus I times what I just went through this. How did it fall out of my mind? Hold times I, right? Times I. If the distance is greater than the self distance, we only want winners, then winners plus equals 1. And then we return the winners. This needs to be a mute. This does not need to be a mute. Okay, so given the races for part 1, we can just do races.iter.map winners, but instead of the sum, it'll be the product. Is that one? Unwrap.1. And then we print line part 1. So for the test input, it's 288. Was that right? Yep. Okay. Should we try it for the actual input then? See if we got the right answer. I guess I'm a little worried. I mean, I don't feel like this is going to work for the part 2, but that's the right answer. Okay, so we got part 1, and that was really just a brute force approach. We're just going through all of them, trying them all, finding how many will win. Oh, you know what would be an interesting thing is one way to minimize it. We'll see what the part 2 thing is, but there is in part 1, there's some point where you start winning and some point where you stop winning. And if you can find out, what I'm saying is you can probably go in both sides and find it, and then the answer is the difference. We'll try that and see if that works too. Determine the number of ways you can be. Okay, that's part 1. So part 2. As the race is about to start, you realize the piece of paper with the race times and record distances you got earlier actually just has very bad kerning. Oh, I actually know about kerning. My wife is a editor. She was an editor for most of her work life, and when we were on one of our dates, I asked her about the things that she does, and I learned about kerning. And kerning is just like the distance between characters, and so sometimes the quote unquote kerning doesn't look right in a word and a font. And so you say, oh, I know that's the way the font should look, but you got to squeeze this one in so it looks like it's one word as opposed to two. Anyway, ignore the spaces between the number on each line. Yeah, so see, now we're going to do it. We now have, where we had a small number, we now have one giant number that is the race. You now have to figure out how many ways there are to win this single race. So given this input, you actually now have this single race, and there are 71,000 ways to win it. But again, that's for their test input. What happens when we smash it together? We get 46 million ways. 46 million tests. That's actually not a lot. Should we try and use Rayon again and just see if that solves it for us? I'm tempted to do that just as for the memes, because Rayon is surprisingly super easy to use. Oh, it didn't like my window size. Okay. Hopefully that size is still visible, because I feel like I'll want to look at this. But so for part 2, we're actually going to do the same thing. But we can use Rayon for this mapping. Ooh, it's actually not here that we're doing the Rayon. It's here. So we may have to do some additional work. Okay, well, let's try it without Rayon then, and then let's do it. So what does this mean? The input is actually just if I just got rid of all the spaces, I can probably still parse it the same way. Stir replace. Okay, let's try it. It is going to take the input and the from predicate, which we're just going to do a space, and turn it into this. Before I actually solve it, though, I want to, let's just print out the P2 input to make sure it looks right. $46, $80, $76, $66, $78, $66, 2 and 4, 24. Okay, so that does look right. Let's just see how long it takes. Oh, there won't be spaces there's no spaces anymore. So the parser doesn't quite work. Let's just write another quick parser for part 2. It's just going to be a single race this time. And what do? We say... we can probably just copy and paste here and remove the spaces. And then we just return the finished the input. So there will be a time, there will be no spaces, and then that will just be there won't even be a separated list, there'll just be a digit 1 and a new line. And then the distances will be, I guess this is time, and this is distance. There will not be any spaces, it won't be a separated list, it will just be another digit, which means we got to get rid of this. And then we return race where, yeah, that's right. Oh yeah, we're getting rid of most of this stuff. So we have the time, then this time, and we have the new line. So there's 3 in that one, and there's only 2 in this one. Like that. Mismatched types. I still should call new, but it's because I'm missing a okay in this thing, huh? I actually want to do that again because we're going to do a tuple with the input and we're going to do okay. Like that. Yep. I don't need these because I'm calling my new function. Okay. Let race equal parse p2 input unwrap. And then we'll just call p2 is equal to race winners. We actually don't have to do anything because there's only one race, so we don't have to worry about doing anything. Sure. That came back really fast. Okay, so maybe it's just not as hard as I thought it was. Or I'm getting the wrong answer and I'm going to regret this. My first answer was that. My second answer is this. That's the right answer. Okay. I mean, I don't know that maybe they don't want you to do brute force. Maybe they do. Maybe my input is just smaller than the average person's input. That's possible. Do I want to try it the other way and see if that helps? How would that look if we did fn winners, like find? We want to find the 2 points. We'll just do winners faster. That was my initial thought, is what if we just find the beginning point and the end point, and the number of winners is the difference. So if we do, it will still be this loop, but you'll have something like, you'll say, let mute winner, or let's see, begin is equal to this. And we'll say, we'll go through the whole time. We'll start at 0. And we will let the distance equal to this, right? And then we say if it's self-distance, we then, once we find it, we say begin equals I and break. Now we're going to do the same thing for the end. It will probably finish it for us. Nope, we want to do it. Still self-time. Actually, begin is not a terrible place to start, but we want to do it in reverse this time. Start at the end, and then calculate the distance, and we say if it is, now we found the end and broke. And then our solution is just end minus begin. So let's compare these. Faster, LOLOL, because the whole thing was faster, I guess. They do give the same numbers, so that is a right algorithm. What it means is you only have to calculate a smaller portion. So we know P1 calculated this many. How do we calculate how much P2 did? Or sorry, the faster version. Like, I'm curious how much this actually saves you. How many calculations it saves you. What if we do a counter where we is a pointer to a mute usize, and then for each of these ones we do counter plus equals 1. This is probably a silly way to do it. And then the faster one. Oh, I didn't do them any differently. That's silly. Let P1 faster equal this. But now I want to do let mute counter equals 0 and pass this. How do I pass this? I was worried it was going to be a closure issue, but maybe it's not. Oh, it actually doesn't give you the right answer. That's interesting. It's a substantially larger one. So it doesn't actually work. So that must mean there's some values in between the beginning and the end that are not right. I don't know. Okay, well, I feel like, though, this was definitely easier than day 5. I had to go pen to paper to solve day 5. This one I could brute force it. The faster one doesn't work. That's interesting. That I would think that if you found... Am I wrong in my assumption that once you get to some time where you're winning, all the times are winning until you're not? Like it's not a bell curve? Is there something else I'm doing wrong here? No, not that I can see. It's surely doing fewer calculations, but apparently not the correct calculation, so it doesn't matter. Okay, so I guess... Does that get me back to the wins? And we won't do faster because clearly it doesn't work. Is there something wrong with this? If I find the first one, I break the for loop. And then I start at the end. I go from the last one to the beginning. And then I do same calculations, but I say if my distance is greater than self distance. Is that there you go. There's another AI bug for all you that were the AI haters. I actually kind of agree with the AI hate. Some of it I don't like because I do think we'll see, but if that's the only bug, that's really annoying that it would do that. So let's do P1 faster equal to and then we'll print line P1 faster with the counter. Still not the right answer, but we're closer. We're under, though, actually, so that's interesting. So I actually don't think the quote-unquote faster algorithm is maybe better than. Start at the beginning. And if the distance is greater, do it. And then we start at the end. And if we ever find where a distance is greater, the end is that one? Is it something like this? We were way more off than this, but let's just try it. Oh no, that is. We were off by that much. Okay, so the first one would have done. Let's figure out what the total was. We can do that in P1 too. So if we do this, we can say the number of calculations we ran were races.iter.map r.time, because you would go over each time element and you sum them up. So in part 1, we do about half, somewhere on the order of half. Hey, myopic, I am coding, yeah, code. Let's try it for race 2. This should be somewhat easier, but we can still copy and paste here for part 2, and we'll say the counter is 0 again, and P2 faster is just the race dot winners faster with our counter, and now P2 faster is P2 faster with our counter. Oh, we should do the... Oh, well, we know... Oh, no, we don't. Yeah, we do. It is the... This one, instead of trying to sum it up, it's just the race.time. So instead of doing 46 million calculations, we did 10 million, so 1/4 of the count. So it is technically faster. That's something to think about. Again, I think both solutions apparently work because they are relatively fast, right? I mean, none of them, I didn't even have to use Rayon to get to the solution. I thought I might have to use Rayon to speed the stuff up, but there was no need to. So I don't even need this. Okay, so now that we're done, because we're well into day 6, I'm sure there's some good solutions. Maybe we just go and see what they are. I'm sure there's some mathematical thing that I'm missing. Or some kind of... There's probably some kind of thing. Quadratic equation in part 2. I got mathy today, part 2. Let's look at this one in Go. I'm a big fan of Go. Negative b plus or minus the square root of b squared minus 4ac divided by 2a minus 1 plus 1. Okay, so, whoa, is that correct? So the number of ways to win is based on the quadratic equation? So there was some kind of curve, apparently. I just didn't follow that far enough. I probably would have never gotten here, though, to the quadratic equation. For each race, print ways to win. Parse file contents, read the file, races, error, ways to win, use 1. Ways to win. Yeah. Okay. Yeah, that totally works. I guess. I guess I don't know if it works. Should we try it? I can pop this into a Go thing and try it. It doesn't look like it's using anything crazy. Oh, we may need to change it a little bit. Let's see. Where is it reading its input? From input.text. You don't even need to do any of this. We just assume that we're here. Maybe he has some program that's like getting the inputs and outputs from another place. Part of that was probably the Go build. Was Rust... Go builder. Go build main.go. Yeah, most of that was build time. Okay. So I think that was the right answer, right? Yep. Yeah, that's super fast. That's pretty fast. I don't know comparison-wise how fast it is. Ooh, should we just for fun, I realize we're well into the time here, and we've already solved day 6. maybe it would be fun to try it in Haskell for a little while, but I want to see if what the timings are on these. So if we say let now equal that, standard time instance, and we do right here, we say the elapsed time is now elapsed, and we can do the same for all of these. Oh, but I want to start over. I should do it before I actually do the calculation as well. So do it right here, and then we'll do it right here. I guess it's not right here. We'll do it right here, and then right here, and then we'll go. I just don't think this one turned out to be hard, but it is cool there's this math solution. I mean, I've taken classes in college and stuff like that, but I've not been very good. I do remember the quadratic equation. This one is twice as fast, and this one is like 5 times as fast, right? 4 to 5 times as fast. So this way is definitely, the faster method is definitely faster, but I mean, not any harder than the other one. This one actually feels like it could potentially be relatively easy to do in Haskell. So I am going to, maybe I'll try that. Just give me a second here to set up the Haskell recording.